Okay, perfect. Let's go on to the next topic, which is expressions. Now you'll see I'm declaring three variables here. Two of them are of type int, and they store the values 7 and 2, which is perfectly valid, and the a and b, right? And then you have a double called variable c, and it stores the value of 5.0, which is a decimal, which is also valid. So now we're doing some operations with them, which is where it gets exciting. We're just printing out the result of each of these operations in the parentheses. So we're not using string literals anymore. We're not just printing out strings or just a variable. Like last time we printed out GPA. We're not doing that anymore. And we're actually printing out actual values of an arithmetic operation. So what are we doing? Well, in Java, you have the same operators as you do in real life math. So you have plus, minus, the multiplication operator, which is represented by a star, and then you also have the division operator by a backward slash. And you also have one special thing, you may have noticed it right here, and basically that's the modulus or modulo operation. And we'll get into that a bit later. But let's just look at what's going to happen in this first statement. Right? So we're basically dividing, right here, we're dividing the value of a by b. And this is something we can do with variables. So right here, what we want to do is we want to substitute the values of 7, right? And then we have the division sign, and then we have 2. And what will that give us? Well, that gives us a value of, in real life, it'd give us 3.5, right? Because we have a decimal. 7 doesn't divide equally into 2. And we won't have, we're going to have a decimal here. But that's not how things work in Java. Not exactly. While that be the correct answer, what you'll notice here is that these two variables, int a and int b, are of type int, right? So we're dividing two integers. And this is a special concept in Java called integer division. And integer division in Java basically means that when we divide two integers by each other, we cannot, because two integers divided by each other have output int as well. So we cannot have a decimal. We have to have an integer. So in regular arithmetic, when we divide 7 by 2, we get 3.5, as we discussed earlier. But we cannot have this 0.5. We discard it. We discard any decimal, that any remainder, per se. So you can think of this as just dividing 7 by 2, getting 3, and then having a remainder of 1, but then ignoring the remainder entirely. Because we're dividing an int, right here. We're dividing an int by an int. So an int divided by int in Java has to give an int. So the answer to this would be 3. And basically, this line of code would print the number 3. Let's go to the next one, which uses the modulus operator. Okay, and the modulus operator, what it does is it basically gives the remainder of the division between a and b. It's kind of complicated, but once you learn it, it's pretty easy to get the hang of it. So what we want to do when we want to figure out a modulo b is we want to take the value a, which is 7, and then we want to take the value b, which is 2, and we want to divide them. In your head, mentally divide these two. And we want to come up with a remainder answer. So as we saw earlier, 7 divided by 2 with a remainder equals 3 remainder 1, right? Now in this case, which is kind of like, you could see the opposite of integer division, we want to get rid of the actual answer we get. And this is the result of the modulo operation. So a modulo b equals 1. So you can think of modulo as basically the remainder of division between the two numbers. So the output of this would be, 1. Okay. Let's now go over this statement. Now you can see that we're actually bringing in the C term. But notice that C is a double. So this is going to complicate things a bit, but it's still going to remain fairly simple. So let's walk through this. Java, like in real life arithmetic, follows the order of operations, which basically means that division and multiplication come first before addition and subtraction. So knowing that, we know that we have to multiply B and C first before we can add whatever the output of this is. So we know that this comes first. Right, so I can just basically put imaginary parentheses just to denote that this comes first, and we're just going to multiply B and C. So what's the value of B? B is 2, and we multiply that with the value of C, which is 5.0. Now you'll notice that this is an integer, and this is a double, right? This right here is a double. Now what does that mean? That means that our answer must be a double. Whenever we multiply an integer by a double, the answer will always be a double. So 2 times 5.0 will result in 10.0. We have to keep this decimal right here because we know that the answer is a double. Now, given that this is 10.0, we now have to add a to it. So now we do the value, basically, I'm just going to cut that off, a plus 10.0. What does that equal? Well, we know the value of a is 7, and the value of, we have 10.0 here. And now, again, we have an integer, and we have a double. Whenever we do any operation between integer and double, the answer must be a double, so the answer to this is 17.0. So right here, the answer right here is 17.0. Let's move on to the last statement, and we can notice that we're adding parentheses here. And just like in PEMDAS, parentheses take precedence over multiplication or division, and then those take precedence over addition. But in this case, we have parentheses over the addition. It's the same, you will notice that it's the same expression over here, but it's just been changed, so the parentheses around the a plus b. So we have to do that first. And that's pretty simple, right? We're just adding a, which is 7, to b, which is 2. That's basic. That's just the same as it would be in real life, and the answer is 9. And then we're taking the multiplication sign, let's bring that down, and we're multiplying, right? We're multiplying that by the value of c, which is 5.0. Value of c is 5.0. So 9 times 5.0 is 45.0, because we need the 0.0 because it still remains a double. Because whenever you do any operation between an integer and a double, the answer must be a double. So the answer to this expression, or what will be printed out on the screen, would be 45.0. And that wraps up expression.